All right, AP Calc, I'm back to give you some examples of how to work with trig in the context of product rule, quotient rule, and of course power rule, and any of the other ones that we've talked about so far. So check out number 9. It's in the textbook, page 125. You're given a function g with respect to t of t cubed times sine of t. So basically, if you have a t value that's separated from another t value function, you must use product rule. So I can't just take this derivative, and then multiply them together. I've got to do product rule. First times the derivative of the second. So the derivative of sine, we proved it was cosine. And then you add that to the second times the derivative of the first, which is just 3t squared. So check that out. First times the derivative of the second, sine over cosine. By the way, I'll probably just, you know what I should do? I should write that chart up here so that you guys can reference it with me. All right, so sine becomes cosine. Cosine becomes negative sine. Tangent becomes secant squared. Cosecant becomes negative cosecant cotangent. Secant becomes secant of x tangent of x. And then cotangent becomes negative cosecant squared. So we've got this to reference every time we're trying to find the derivative of something. At any rate, there's not much more to do with this one, but maybe just rewrite it like this: t cubed cosine of t plus move this to the front. Usually trig takes the back seat ride. All right. And it's not a bad idea to put your angle in parentheses just to kind of say it's not just sin, it's the sin of t. All right, check out the next one. Looks like I gotta do product rule twice. Why don't you guys pause the video and try it on your own? Okay, let's check it out. 2x and cotangent of x. It requires us to do product rule. So first times the derivative of the second. Cotangent's derivative is negative cosecant squared. Negative cosecant squared of x plus the second cotangent times the derivative of the first, which is 2. And that will be the derivative for 2x cotangent of x. Move on to the next one. Might not be a bad idea to just do this to keep track of your terms. Next, we have first times the derivative of the second. Tangent's derivative is secant squared plus the second times the derivative of the first. So these become horizontally lengthy algebra problems. There's not really too much simplification that can happen here. I mean, I can bring this negative out in front of the 2x, cosecant squared of x. I can bring the 2 out front here, cotangent of x. This doesn't really change. And then the 2x can be brought out front here. So I don't know, I feel like this is good enough for the answer. I'm sure there's another way we can think our way through this, but we're not going to right now. It's as far as simplifying it. Okay. Oh, quotient rule. Let's do it. Number 13. Remember, h prime of z. Remember quotient rule? Bottom, unchanged, times the derivative of the top. So, the derivative of 1, 0. Derivative of cosine is negative sine. So it's 0 minus negative sine. So it ends up being positive sine of z. That one was kind of tricky because cosine's derivative is negative sine, but it was already negative, so negative negative makes it positive. Subtract the top. Times the derivative of the bottom, which is just going to be 0 plus negative sine of x. All divided by the bottom squared. All right, so what's happening here? Well, I can distribute the sine of z to 1. And then it's sine times cosine. And then it's negative, negative sine of z. So when I multiply a negative, negative sine of z, it becomes a positive 1z. Or positive 1 sine of z. And then this one's going to be negative, negative, right here. All over the bottom squared still. So let's see. Can you guys see all that all right? Maybe. So what happens? You should be canceling out your sine cosine with your sine cosine. And then combine these two. 2 sine of z. All divided by 1 plus cosine z squared. And that'll do. So there's really actually not a whole lot of computation that you've seen so far. A lot of it's just, can you use these properly, and do you know product rule and quotient rule? I have some more examples, but maybe they're not needed. Let me check this over really quick. No, we need 15 for sure. Or was it 17? 15, okay. Yeah, I wanted to show you a couple different ways in which to do 15. G of x equals 1 over sine x tan x. Okay, so if we did no analysis beforehand, this is what the derivative looks like. We gotta do quotient rule. Bottom times the derivative of the top, which is 0. So bye-bye. Minus the top times the derivative of the bottom. We got to use product rule. So it would be first sine of x times the derivative of tan, secant squared, plus the second tangent times the derivative of the first sine would be cosine, all divided by the bottom squared. So sine squared, tan squared. All right, what does that give us? Well, it gives us negative sine of x secant squared of x minus cosine of x tangent of x. All over sine squared, tan squared. I'm just curious what this looks like here. I'm going to do a little off to the side calculation. If I turned everybody into sines and cosines, I'd get negative sine of x over cosine squared of x for this part. For the second part, I'd get minus cosine of x over 1 times sine over cosine. So those cancel. Negative sine of x. Well, that's interesting. I could technically say that this was the same as negative sine of x over cosine squared of x minus sine of x. You could factor out a negative sign, and you'd be left with 1 over cosine squared plus 1. We can cancel out a sine on top with a sine on the bottom. This is the same thing as secant squared. And I think that this is a pi identity. If you go to your formula sheet, well, it's not 1 plus secant squared. It's 1 plus tan squared. So I guess it doesn't really take us much further. At any rate, I think there's a lot of... I'm so sorry, you guys couldn't see any of that. Bottom line is, there seems to be a lot of stuff happening under the surface when you do 1 over sine of x times tan of x. There's another way to do this, and that's simplifying at the very beginning. So I kind of left that one in a weird state. Say you don't want to use quotient rule. Okay. What can we do? Well, you can rewrite it like that. We still have fractions, but you have reciprocal identities that say 1 over sine is cosecant. 1 over tangent is cotangent. I don't think we need to use quotient rule anymore. But you need to use product rule. First times the derivative of the second plus the second times the derivative of the first. Now there's still some analysis we could do. You could factor out a negative cosecant of x and really explore what that might have. Cosecant squared plus cotan squared. It almost looks up like a pi identity, just like this one almost looked like a pi identity. Sorry. But when I check out the pi identities, it's supposed to be 1 plus cotangent squared equals cosecant squared. I can only get cosecant squared minus cotangent squared out of that. So this actually doesn't give me anything more. Or does it? I could replace cotangent squared cosecant squared minus 1. All right, can you guys see that? Which is negative cosecant of x times 2 cosecant squared x minus 1. Okay. We were able to rewrite it all in terms of cosecant. So yeah, the next video I do, which looks like there's going to be one more. We got 3 more problems to do. I think this is a good stopping point. But the bottom line is, it's not just do you know your basic derivatives, but can you do a little bit of sort of like that trig proof, that trig simplification, that algebra manipulation before you actually take the derivative. Because sometimes it's worth your while, creates very simple things. And other times, I don't know, you just go around in circles a few times. Anyway, we learn from those weird mistakes, so that's all I got. Part 3 coming up.